Hello everyone, I am Shruti Vijayargi from BISP Solution. In my previous video, I discussed about the t-test, and this video I am going to tell you about the z-test, and also I will explain you the difference between the t-test and z-test. So what is z-test? A z-test is any statistical test for which the distribution of the test statistic under the null hypothesis can be approximated by a normal distribution. Because of the central limit theorem, many test statistics are approximately normally distributed for large samples. So the z-test is performed to make inferences about the population mean based on the sample mean and the given population standard deviation. The z-test is also performed to make inferences about the population proportion based on the sample proportion. So the formula for the calculation of z-test is t equals to x to the x bar minus mu upon sigma divided by square of n, where x bar is the sample mean, mu is the specified value to be tested, sigma is the standard deviation, and n is the size of the sample. So let us understand this with the help of simple example. I have an example of z-test. So a herd of 1500 steer was fed a special high protein grain for a month. A random sample of 29 were weighted and had gain an average of 6.7. So we have average x bar will be 6.7 and total number of sample will be 29. If the standard deviation of weight gain for the entire herd is 7.1, so 7.1 will be our standard deviation. Test for the hypothesis that an average weight gain per steer for the month was more than 5 pounds, so mu will be 5. So first we have to calculate x bar minus mu. So select the cell, type an equal sign, select the cell x bar minus mu, then enter. Then we have to calculate sigma divided by root of n. So we have standard deviation, select the cell, divide square function and then n. N is total number 29 and enter. So the z test will be x bar minus mu divided by standard deviation divided by power of n. So 1.28 will be the z test value, and the tabulated value for this will be tabulated value for 1.28 will be, so here is 1.2, and for the 8th column 0.08. So this will be the value for 1.28, 0.8997. So this will be subtracted by 1, that means 0.1003. So the conditional probability that a sample from the herd gain at least 6.7 pounds per steer is 0.1003. This is the probability. Should the null hypothesis of a weight gain of less than 5 pounds for the population be rejected? That depends on how conservative you want to be. If you had decided beforehand on a significance level of p less than 0.05, the null hypothesis could not be rejected. Okay. So a z-test is a hypothesis test based on the z statistic which follows the standard normal distribution under the null hypothesis. The simplest z-test is the one-sample z-test which tests the mean of a normally distributed population with known variance. For example, the manager of a candy manufacturer wants to know whether the mean weight of a batch of candy boxes is equal to the target value of 10 ounces. From historical data, they know that the filling machine has a standard deviation of 0.5 ounces, so they use this value as the population standard deviation in a one sample set test. You can also use Z-test to determine whether predictor variables in probit analysis and logistic regression have a significant effect on the response. The null hypothesis states that the predictor is not significant. You also have the option to use a Z-test to do a normal approximation for test of portion rate and test of proportions. These normal approximations are valid when the sample size and the number of events are adequately large. So we studied how Z-test works in Excel, but it is much similar to t-test, but there are some differences between both of them. Sometimes measuring every single piece of item is just not practical. That is why we develop and use statistical methods to solve problems. The most practical way to do it is to measure just a sample of the population. Some methods test hypotheses by comparison. The two of the more known statistical hypothesis tests are t-test and z-test. So a t-test is a statistical hypothesis test. In such test, the test statistic follows a student's t-distribution. The t-test is also referred to as the student t-test. It is very likely that the t-test is more commonly used statistical data analysis procedure for hypothesis testing, since it is straightforward and easy to use. Additionally, it is very flexible and adaptable to a broad range of circumstances. There are various t-tests, and two most commonly applied tests are the one-sample and paired sample t-test. One-sample t-tests are used to compare a sample mean with the known population mean. Two-sample t-tests, on the other hand, are used to compare either independent samples or dependent samples. So a t-test is applied, at least in theory, if you have a limited sample size of n less than 30, as long as the variables are approximately normally distributed and the variation scores in the two groups is not reliably different. It is also great if you do not know the population's standard deviation. With the standard deviations known, then it would be best to use another type of statistical test, which is the z-test. So the z-test is also applied to compare sample and population means to know if there is a significant difference between them. Z-test always use normal distribution and also ideally applied if the standard deviation is known. Z-tests are often applied if the certain conditions are met, otherwise other statistical tests like t-test are applied in substitute. Z-tests are often applied in large samples of n greater than 30. When t-test is used in large samples, the t-test becomes very similar to the z-test. There are fluctuations that may occur in t-test sample variances that do not exist in z-test, and because of this, there are differences in both test results. So this is how z-test works. If you have any doubt, you can ask me. Thanks for watching.